All right, we need to finish up 3.6. We just barely got started yesterday, so let's kind of review what we're doing here. So we're going to have polynomial and rational inequalities, and we're trying to find the solution sets. And so right now we're kind of focusing on the polynomials. And so we had one here which was in the quadratic form, which is where we're going to have the parabolas. The graphs can be kind of helpful to help you kind of visualize it, but what's going to help us is if we just can follow these directions right here. And so basically you want to find the x-intercepts, and then you need to figure out if those x-intercepts are part of the solution or not. And so in our first example, they were not. So 5 and 2 make the expression on the left equal 0, but 0 is not greater than 0. So those came back as being false. And so we had to put open circles at those 2 points on my number line. Then from there, so you find the x-intercepts, then you have to test a value between the x-intercepts and beyond the x-intercepts on each side. So we had three sub-intervals. And so you test those points, and if they come back true, that means that all the points inside that interval are true. And if it comes back false, that means all the points inside that interval are false. And so this is, oops, this is what we got on our first solution set here. And so what you will notice a pattern of like true, false, and so on, but that's not always the case. So just kind of be careful. Whenever you're testing the sub intervals, you might kind of feel like, oh, it just always kind of has that pattern, but it can go true, false, and stuff like that. And we'll see a couple of those later on, but it is true for the most part. It does go back and forth. But anyways, let's go ahead and jump in on one. And I have to apologize, but I know I already have a little typo on part B. That 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 should be a minus 18. So I'm gonna go ahead and switch that. Okay. And so I'm sorry, I redid my notes and there's little typos here and there. So okay. So let's just start from square one. You want to find the x-intercepts. And so we want to factor this. We'll do the A and M method. Basically, what multiplies to give me negative 18, but add up to negative 3. Well, let's see. I think that would be a minus 6 and a plus 3. Those multiply to give me negative 18. They add to give me negative 3. So my x intercepts are at 6 and negative 3. And then the next thing I have to do is I have to figure out, okay, when I plug that in, that will make this equal 0, right? Is that true or false? Is that true or false inequality? And it would be true. It would be true because when you plug that in, you get 0, and 0 is less than or equal to 0. So when I put those values here, I do want to go ahead and fill those in with closed circles to indicate that that's part of my solution set. Okay. All right. So then the next step is to test values between and beyond. So let's see, we should probably test, let's see, I'm going to draw some lines here to differentiate. Let's see, over here I need to test something, let's pick something simple like negative 4. So we'll pick x equals negative 4. And then here, if 0 is available, 0 is always an easy one to use. And then let's see, then over here we'll probably pick like 7, x equals 7. So those are the 3 points that we need to go ahead and test. And so I would plug it into the factored form. You could plug it into the original if you want, but I would just plug it into the factored form. And so we're just going to plug it in for x right there. So we're going to have like negative 4 minus 6 times negative 4 plus 3 is less than or equal to 0. And so let's see, this would give me negative 10 times negative 1 is less than or equal to 0. And so we're testing it. We're trying to see if that's true. Okay. And so let's see, that would give me 10. Positive 10 is less than or equal to 0. Well, that's false. That is false. So I don't want to shade this side of the interval right here. Okay, now 0. Now I'm going to plug in 0. And I'm probably not going to have quite enough room, so this first step I'm going to kind of do it in my head. 0 minus 6 is negative 6. And then 0 plus 3 is positive 3. So I'm going to do that first part in my head. Is that less than or equal to 0? Well, when I multiply that together, it's negative 18, which, yes, that is less than or equal to 0. In this case, it's less than, right? So this will come back as true, and so I'll go ahead and shade that part of my number line. And then my last one is 7. Once again, I'm just going to kind of do this first part in my head. 7 minus 6 is 1, and 7 plus 3 is 10. Is that less than or equal to 0? Well, no, that multiplied together is 10, which positive numbers are not less than or equal to 0. So that's going to come back as false. And so that doesn't work. So now I'm ready to go ahead and give my answer, which we want to give in interval notation. And so it's going to include my endpoints. So I'm going to use brackets. So anything between negative 3 and 6, and including those values, if I were to plug them in, would give me a true statement for my inequality right there. Okay, let's try, I think I've got one more. And so we kind of have to clean this up a little bit here. And um, unfortunately, I noticed another little typo. I apologize. Let me go ahead and fix this. We're going to change that to a plus right there. And I'll have to fix my notes for next semester. So sorry, y'all were kind of the guinea pigs with the new software program, but hopefully it was worth it. Save a couple bucks. All right. So now we're ready to go. And so I need to go ahead and set the inequality equal or set it to 0 so that then I can factor it and basically do the same process we did on the previous page. So not much different, but I have to clean it up a little bit from what we saw on the previous page. So I'm going to subtract 10x and subtract 24 from both sides of this. So minus 10x minus 24. And let's see, so we're going to have x squared minus 10x minus 24 is less than 0. So I kind of cleaned it up a little bit. And now we're ready to go ahead and factor this. And so this should factor into, let's see, x minus 12 and x plus 2. Is that less than 0? So that's what we're trying to get to the bottom of. And so the first thing we want to do is figure out our x-intercepts. So our x-intercepts would be at 12 and at negative 2. Those are the two values that would make this expression and the original one, same thing as this, would make that 0, right? And so, yes, both of those values make it 0, but that would become a false statement because 0 is not less than 0. So we do need to start by putting those on my number line, but we will put open circles at those values because they are not included. But some bumping up to those may be included, so we'll see. So then the next thing is just to test some points between and beyond on the edges. So over here, we'll probably test like negative 3 would probably be pretty simple. Then here, once again, 0 is always a good option. And then over here, we'll test 13. Test 13. Um, all right, let's move this up a little bit. All right, so once again, I probably am gonna run out of room, so I'm just gonna plug it in and do the first step in my head. So when I plug in negative 3 into this inequality, let's see, negative 3 minus 12 would be negative 15. And then negative 3 times positive, or I'm sorry, negative 3 plus 2 would be, what is that, negative 1? And let's see, is that product less than 0? Well, when they get multiplied together, it's positive 15. 15 is not less than 0, so that is going to be false. So we don't want to shade that spot. Then let's see, if we plug in 0, we're going to get negative 12, and then 0 plus 2 is 2. Negative 12 times 2, is that less than 0? Well, yep, because when we multiply that together, we get negative 24, which is less than 0. So that comes back as true. So this one looks like it's going to be pretty similar to our previous example right here. There we go. And then let's see. Um, then our last part of it, let's see, x equals 13. So 13 minus 12, let's see, that would give us 1. 13 plus 2, that would give us 15. Is that less than 0? Well, yeah. Let's see, 15. Nope. 15 is not less than 0, so that's actually false. So we don't want to include that one. So this one was very similar to the previous example. What would be different is that our endpoints are not included, so we're going to use a parentheses from -2 to 12. So everything between those values, but we don't actually get to include the actual endpoints of -2 and 12. All right, so now we're gonna stay with polynomials, but we're gonna go beyond just having the quadratic with the x squared. We'll go to higher powers, and what that will cause is the possibility of having more x-intercepts. And so that just creates more subintervals to kind of check. And so this first example, I do give a picture just so we can kind of interpret it a little bit better. But then moving forward, you won't have the picture. And so once again, just follow the rules. The rules are find the x-intercepts and then test points between them. And so on this one, we would have to factor this. And so let's see, there's 4 terms, so maybe we can do factor by grouping. So on the first set, we can pull out an x squared, and that would leave us with x plus 1. And on the second set, we're going to pull out a -4, which would leave us with a positive x plus 1, which is good, because then we have that match that we can factor out right there, the x plus 1s. So we're going to factor out the x plus 1, and that will leave us behind with the x squared minus 4, which then we can factor that. That right there is the difference of 2 squares. And so let's see, x plus 1, then this will factor into x plus 2, x minus 2, less than or equal to 0. So the difference is now we've got 3 factors. We've got 3 x-intercepts. And so my x-intercepts for this would be -1, -2, and +2. So those are my x-intercepts. Those are what will cause this to be 0. And if it's 0, it comes back true. So if you look here, if you plug in this, you'll get 0. If you plug in any of these numbers in for x, it does come back as a true statement because 0 is less than or equal to 0. So now what I have to do here is put these numbers on my number line. We want to go in numerical order and try to space them out a little bit so you can do the math to check your subintervals. So let's see, um, I'm going to put -2 right here, and I'm going to put -1. I got to space it out a little bit because I got to have some room to do some math in the middle. And then let's see, we'll put +2 over here. So there we go. So I've actually got 4 intervals I have to check. Now, I do know that all 3 of those points actually work. So I'm going to go ahead and fill in right here. Fill in that right there. Okay. And so I need to test something here between -infinity and 2, between -2 and -1. Let's see, -1 and 2, and then from 2 to infinity. All right. Okay. So let's see. What are we going to test? Well, I'm going to go ahead and draw my lines to kind of get my spaces. So I'm going to have to test 4 different things. So over here, I'll probably test like, x equals -3. Now, this won't happen very often, but it might come up every once in a while that you don't have a whole number. I'm going to have to test a decimal. I know that doesn't sound like fun, but it really shouldn't be that bad. We'll test -1.5. That would be like right here in the between -2 and -1. It won't be that bad, and if you need to, you can use a calculator to kind of help you out, but you'll see it won't be terrible. Um, And then let's see, between -1 and 2, 0 is always a good one. So we'll test x equals 0. And then over here, between 2 and infinity, we'll test 3. We'll test positive 3. So those are the four values we need to test, and each one of those is within these sub intervals. And if it's true, great. Then it's part of the solution set, and if it's false, then it's not. So let me come down here a little bit. Okay, so let's see. We'll start with -3. Once again, I'm not going to have a lot of room, so I'm just going to have to do this first part in my head where I plug it in. So let's see. -3 plus 1 would be -2. So that first value would be -2. Then -3 plus +2 would be -1. Okay. And then let's see, -3 minus 2 would be, what is that, -5. And then the question here is that less than or equal to 0? That's what we're trying to figure out. And so you're going to multiply all three of these numbers together right here. And if you want to, you can use a calculator. But let's see, -2 times -1 is 2. And then 2 times -5 is -10. So -10 is less than or equal to 0. True. That is true. -10 is less than or equal to 0. So we're going to shade that part right here. Okay. And once again, on this first example, you won't always have the graph, but I kind of supply the graph so we can kind of see here. There's our x-intercepts that we are already put on our number line over here. And you can see that this is below the x-axis, so those are negative results. The y value is coming back as negative, so I'm getting negative results, and that's what we were looking for. We wanted to get values less than or equal to 0. So you can already see that the next part will come back as being false, because I'm going to get positive values, and then I'll get negative values again, and then I get positive values. But we're going to go ahead and go through the process, though, because, like I said, you won't always have the picture. But sometimes seeing the picture can kind of help give you a little bit better understanding of what's taking place. Now let's try the -1.5. I know it's not going to be fun, but it's not that bad, especially if you need to use a calculator, that's fine. So let's see, -1.5 plus a +1 would be -0.5. So my first value is -0.5. Then let's see, -1.5 plus a +2, that would be a +0.5. And then the last one, let's see, -1.5 take away 2, that would be -3.5. -3.5. And I'm going to move this line over a little bit. I'm going to need some extra space. So, okay, and then we want to figure out, is this less than or equal to 0? Okay, well, you can multiply it together with the calculator, and that's fine. But what kind of stands out to me is that I know that if I multiply a negative times a positive, that's going to give me a negative, right? And then a negative times a negative is positive. And I know that positive numbers are not less than or equal to 0, right? Positive numbers are not less than or equal to 0, so that would come back as false. So I didn't even have to actually multiply the numbers together. I could just see a negative times a positive is negative. A negative times a negative times a negative comes back as a positive number. So I don't even know what the number is, but I know it's positive. And positive numbers are not less than or equal to 0, so that's false, so I know not to shade there. Okay, now let's try 0. So we plug in 0 in all those spots. Let's see. I'm going to get a 1 times 2 times -2. Is that less than or equal to 0? Well, yeah, when I multiply this all together, I get -4, which, yeah, that is less than or equal to 0. So that comes back as true. So we'll go ahead and shade that part right there. And then let's see, our next one is 3. We're going to plug in 3. So let's see, 3 plus 1 is, what is that? That's 4. 3 plus 2 is 5. And 3 minus 2 is 1. Is that less than or equal to 0? Well, it's a bunch of positive numbers getting multiplied together, and it comes back as +20. And positive 20 is not less than or equal to 0, so that is going to be false. So now it's time to fill out our interval notation. So the first part of my solution set is from negative infinity to negative 2 and including negative 2, right? And then union from negative 1 to positive 2, and then we'll go ahead and bracket that in right there. And you can tell by looking at the graph there that, yeah, that kind of makes sense. All those values are coming back as negative results because it's important the inequality plays an important role, because if you flip it, then you'd get the opposite. You'd want the values that are above the x-axis if it was greater than 0. But anyways, all right, let's do another one. Okay, so here we are. Once again, we kind of saw something like this earlier where you kind of need to um, set one side to 0. So we're going to go ahead. I'm going to start by subtracting 9x squared from both sides. So subtract 9x squared. So I get x cubed minus 9x squared is greater than or equal to 0. All right. So let's see, what can I factor here? Well, let's see, I believe I can pull out an x squared, and that will leave me behind with an x minus 9 is greater than or equal to 0. And so I have two solutions, two x-intercepts, and those would be at 0, and the other one would be at positive 9. That's the two values that would make this expression on the left 0. And those would actually come back as true. Right? Both of those will come back as true. All right, so let's go ahead and put those on the number line, and we'll see what we can do here. So 0 and a 9, and they are true, so they are included. So I'm going to go ahead and fill that in. Okay, and now I need to test some points. So let's see. I'll test like right here at x equals negative 1. That should be an easy one. Then right here at x equals positive 1. And right here at x equals 10. So that's where I'm going to test those subintervals. And you don't have to put those on the ends, but sometimes I like to do that. All right. Um, So once again, we'll probably plug it into the factored form. That's probably going to be the easiest thing. So I'm going to plug it in here and here. And I'll kind of show my math a little bit more here since there is an exponent, since we have the x squared. So let's see, I would have negative 1 squared and then times negative 1 minus 9. And we want to figure out, is that greater than or equal to 0? Is that greater than or equal to 0? Okay, well, negative 1 squared becomes positive 1, and then negative 1 minus 9 becomes a negative 10. And when you multiply those together, you get negative 10 is greater than or equal to 0. Well, that is false. Negative 10 is not greater than or equal to 0, so that's going to be false. So we do not want to shade that area. All right, now let's go ahead and try positive 1. So let's see, we plug in positive 1. So let's see, we're going to have 1 squared times 1 minus 9 is greater than or equal to 0. Well, 1 squared is 1. 1 minus 9 is negative 8. And when I multiply that together again, I get a negative 8 is greater than or equal to 0, which is not true. That is false. So see, that pattern got broken. Typically, we've kind of gone true, false, or whatever. And in this case, we're having a false, false. So neither of these subintervals work, but be careful. That 0 is still part of my solution set, because when you plug in 0, you do get a true statement if you were to plug in 0. Okay, let's see. What about 10? What about when x is 10? So let's see. We're going to have 10 squared times 10 minus 9. Is that greater than or equal to 0? Well, 10 squared is 100. This 10 minus 9 would be a 1. Well, when I multiply that together, I get 100 is greater than or equal to 0. Well, yeah, 100 is greater than 0, so that's true. So we did get a true. So that's going to be this part of my interval right there. Okay, so now when I put my solution set, I do need to include 0. So we include 0 like that, and then we're going to union in 9 to infinity, and we include the 9. So 9 to infinity like that, and that's my solution set. And in case you're kind of wondering how this looks, like why did it come back false, false? Well, what happened here, if you were to graph this at 0, what happened is the higher order polynomial came up to 0 and bounced off because that multiplicity was a 2. So that kind of goes back to one of our previous lessons. So the multiplicity of 2 caused that x-intercept to bounce off, come back down, and then it came up through over at 9 right there. And so we were looking for values that were greater than or equal to 0. So right here you were equal to 0, and then when I went through the 9 and went up, that's where I had that other part of my solution set. So okay, so my video is kind of going long, so I'm going to go ahead and stop here and make a part 2.